Please give a big round of applause for having Mr. George Salazar with us. He has an extensive experience of working with NASA for almost 40 years. Recently retired from NASA, and I think has got more busy than during his actual tenure. It is very difficult to find time from sir's schedule. So I, once again, sir, with all heartfelt thanks, invite you. We are really grateful for you to take out time for our students.
Thank you, Arpit, for inviting me. Good morning, good afternoon, good evening, students, wherever you're located. Let me just say a few things about myself in terms of my work at NASA. As Arpit mentioned, it's 40 years, and I did a lot during that time. I worked in speech recognition. I worked in flight computer development for the space shuttle, as well as the X-38 experimental spacecraft.
What kind of programming engine does NASA use?
What kind of programming engine? So we use many different kinds. So there's something called embedded real-time programming. So this kind of programming is used for developing what we call special computers. Okay, so the computers that we use on, let's say, on the space station, and eventually the ones that we're going to be using to go to Mars and the moon, they're special computers. They're not like your laptop. They don't look anything like your laptop. They look like these big blocks of metal.
Sir, I'm very glad to meet you. So I am here with two questions. One is, so when did you start this journey? What inspired you to start this? And the second question is, if Mars is the second planet where life may be possible after a century or two, what is the third planet where life can be possible after more years?
I like actually electronics a lot. I did electronics repair. But when I was going to the university, I got to learn or know some engineers from NASA here at the Houston Johnson Space Center in Texas. And I started to get interested in it. So when NASA came to the university to interview, I interviewed with them. And they liked what I did. They liked my background and everything. And so I got a job offer and came to work at NASA. Mars is going to be challenging, and there's potentially life there, but there's a lot of things that we need to learn and ahead of time. That's why we send a lot of probes over there, or satellite probes. We send rovers over there. They're called, basically we're scouting the areas that potentially one day we'll go and land on there. And so we need to understand what happened to Mars. Mars lost its atmosphere, most of its atmosphere, but yet it still has a small magnetic field, not as strong as the one that we live here on Earth. Our magnetic field is very strong, and thank goodness it is, because it protects us against galactic radiation for the most part.
Good afternoon, sir. Good afternoon from Dubai. My name is Aditya Kashyap. Really nice to meet you. I had a question regarding NASA's missions to space, and when you look at the recent events, like a few piloted missions when it comes to space, like how is NASA really incorporating machine learning or predictive analysis, that kind of technology, into spacecraft systems in order to anticipate failures even before they occur when it comes to risk to life and other kind of threats that may pose harmful to human life?
Well, the whole thing about a space mission is, first of all, understanding what the objective is, and then, based on the objectives, we develop systems, for that objective. For example, the Dragon system of SpaceX, its objective is to take humans or astronauts to the space station and then return them safely back home. but so it depends on what is needed for that mission. So let me give you the example of the Dragon. Okay, so the Dragon uses I think for the most part they use a little bit of artificial intelligence, but not a whole lot. There's still some issues with artificial intelligence flying on the spaceship, and one of the reasons for that is because artificial intelligence can change its behavior, and NASA doesn't like that. I can tell you that when we build systems, we test them, and the terminology that we use is testing for determining.
I have a question for you. Do you ever find any ancient cosmologies that align with any modern astronomical findings?
Oh, okay. So you're talking about early astronomy compared to today's astronomy, and there's just a whole bunch of that. I mean, you talk about the Greeks, the different Egyptians, that knew things about the star movements, and it's just amazing. That's not my area, but I find it interesting. We did a trip to let's say England, and went to the Stone Age, place where they had those stones that align with different parts of the universe. And of course, this is a somewhat of a primitive way, but I mean, they could predict, the seasons and things of that sort. And of course, before the telescope was invented by Galileo, I mean, they just looked at the stars and made observations. Thank goodness they didn't have cell phones, because they could spend more time looking at the stars and learn about things.
So I had a question. So if you have ever worked with a black hole physicist, I wanted to ask what would be important to study to become a black hole physicist, and aside from that ultralight spacecraft which we are working on, what projects are humans working on that could get us to other systems as soon as possible? Thank you.
You cannot put a probe to go into the black hole, because you'll never see it again. It's a very intense gravitational pull. If you get to what they call the event horizon, which is the very outskirts of the black hole, that's about as close as you're going to get. After that, you're going to get sucked right in.
From how far would in light years would it take to see the creation of the sun?
And so right now, the estimation of our solar system is about 4 billion years old. So that means that if you go back 4 billion years, you start seeing the formation of the sun, and the formation of our planets surrounding the sun. And there's a lot of interesting theories about that, about the formation of the sun. But the sun is pretty much a big ball of helium, and that's basically producing the energy for the light, if you will. And eventually that helium fuel is going to run out, but it's far away in the future.
All right, sir. Thank you so much, sir. I think a lot of questions have been answered, and questions are still floating in. It must have supplied some level of inspiration, as well as clarification of ideas. All right.
Thank you.
Thank you.
Thank you, everyone.